Hi, my name is Andrew Romans, and this is Project 4 of Artificial Intelligence, my artificial neural network. To start off, I created two classes that represent my neural network, my node class and my link class. Each node class has a enumeration which tells me what kind of node it is. So I have input that shows me it's part of the input layer, hidden, which shows me it's part of the hidden layer, output shows me that it's part of the output layer, or biased shows me if the node is a biased node. From there, the node contains my data, the data before I put it through the squashing function, the delta of the node if there is one. It also contains a list of links, which I will show you in just a second, of the inward edges and the outward edges. From there, it contains functions that determine the data, which is the summation, determine the delta, summation part of the pseudocode, and then the sigmoid and the sigmoid prime functions. From there, there's the link class that contains the weight, the previous weight change, the root node, and the connected to node, which root node would be I, and the connected to node would be J in this instance. There is generating a weight, which only happens once when the graph is created. And then there's calculating data, which multiplies the data of the root node times the weight. And then there's calculating the delta, which is takes the connected to delta and multiplies that by the weight. Then in the main program itself, when I run this function setup graph, it then creates that neural network through the list of nodes. If I was to run down here to that setup graph, it first creates the input layer, and the bias node is added to each layer, creates the hidden layers, and then it finally sets up the output layer. And once all of those layers have been created, it then will connect each of those layers together. And then from there, I'll have my completed graph or unfilled data of network. Um, from there, I have a main loop, which I'll have the opportunity to whether to only train, to only test my data, to either do both record to do both and record each data. So I could train 100 times and then each 100 times I will test it. And whatever that accuracy is, I will record it to a list of doubles. And then from there, it will continue on how many times I designate, and then it will give me all of the information or all of the accuracies in or print them all out for me to read and easily put into Excel. I can set my alpha or I can quit. Here are my two functions that decipher the text files that were given to us for the data. And then there's two functions, one for only testing and then one for learning. Feed forward propagation here shows that it only tests out and then at the end prints out the accuracy of each run through, each set of data. Um, as far as this also contains the feed forward part, but then adds the propagation. So you can see here that it calculates the data for each hidden layer, and then once that's finished, it'll calculate the data for the output. From there, it will then start the back propagation, which then for the output layer, it'll calculate all of their deltas. From there, I'll start back propagating towards the hidden layers, which will then calculate their deltas. And then once all the deltas have been calculated, I will start heading back towards the output layer from the input layer and updating each weight of each link within the graph or the network. And then once that is finished, it will run the feed forward, show me my accuracy, note whether or not it has changed or increased or decreased, and then continue forward. Before I show the program running, I'll show here. Here is all of the data that I've collected of testing, and this is with two hidden layers, one of which was 24 and the other of which was 12. I noticed that zero point 0.6 actually gave the optimal path, reaching to a max of 80%, while zero point 0.2, 0.45, 0.7, 0.9, and 0.95 all gave around 70, high mid 70s, besides zero point 0.2, which gave around 69%. real fast. If I run this, it will tell me I can either R to train, T to test, E to record, A to sell alpha, or Q to quit. Right now I have my alpha at 0.6. So I'll just real quick E, I'll train 100 times and I'll only do it once. So for once, so training number 0 is one full set through of all of the data, and it'll do that 100 times. Once it is at 100, it will then run the feed-forward propagation, which uses the test op digits text file, and then it will tell me what my current accuracy is. At 24 hidden layers, it does pretty well. It goes decently fast, but if I was to increase that to 65, it slows down tremendously. So here we're reaching 99, which will then run the feed forward part. And we'll see our first test set got 53% accuracy for a first tester. So if I was to keep going, um, which I could do real fast, I'll train it again one more time. You'll see that we have our first test set here. It will then increase and it will tell the next set of, or the next accuracy that we've received from our second train through of 100 training sets. Generally, before while that's training, I've noticed that a really pattern that it would have is that it would increase tremendously at first, and then over time it would slowly plateau off, staying around the same value, which seems to be for me 80%. And so see here, last time I got 31% for my first training set group. This time I seem to have gotten 51%, I believe. 53%, which is not bad. And so here about to reach 99. And so we hit 61%. So it's gone up and it's probably going to start plateauing off, I would imagine, around the 80s, high 70s, 80 percentile. So anyway, so yeah, so that's my neural network. Hope you enjoyed it. I enjoyed the project. I believe there are a few things that I could do a little bit better in the future now knowing how artificial neural networks work. Um, but as for the project, I feel quite accomplished and proud of what I've done. And that would be all.